Yes, I'm gonna paste the slides on the chat. Um, I shared the slides in the chat. And I'm gonna share my screen now and let me know if you guys can see it. You guys can see my screen, right? Or okay, got it. Okay. So. Okay, so hi everyone. Are we recording?
Yes,
Okay.
we're recording.
Okay, thanks. Okay, one more time. Oh, hi everyone. Today we will be talking about one of the many serial communication protocols, which is called UART. I'm not gonna go in depth about the concepts of UART. Instead, I'm just gonna do demonstrations using the Arduino IDE and the two microcontrollers that you guys have. These demonstrations I think is sufficient or are sufficient enough to understand the basics of UART and to help you guys accomplish the task for the hack. Once again, the slides are on the chat. I'm gonna copy and paste it again. Okay, there. Okay, so I'm gonna get started. So just to get a basic understanding of UART, I want you guys to watch a short video. I will play it and let me know if you guys can hear it.
What's up, my friends? Welcome back.
Can you hear it? Okay, cool. Okay.
So what is a serial communication protocol? Well, it's a way of transmitting data in a line, one data after the other. And in this case, we are talking about digital data. Imagine that you want to send the number 198, which in binary, which are just ones and zeros, will be 110000110. You could connect a wire for each bit and send the high digital pulse for ones and the low value for zeros, and do that at the same time. So in just one moment, you can send all the bits at the same time. This is called a parallel communication. The downside of this kind of communication is that we have to use 8 connections plus the ground reference, so a total of 9 cables. But this is for 8 bits. Imagine that you want to send a 16 bits data. In that case, we will need 17 cables, and usually we want fewer connections. So instead of sending the data each bit at the same time, what we will do is to place the bits in series, and then we send each one after the other using just one cable. But you could already see the downside of this type of communication. If we send 16 bits in parallel, we need only one clock pulse to send all the data. If we send the same data using serial communication, we will need 16 clock pulses to send the same amount of data. So this will be 16 times slower. So that's the main disadvantage of using serial communication. As examples for serial communication, we have the S-bus, the PPM, the JTAG connection, UART, I2C, the CAN, SPI, MIDI, USB, RS-233, and more. And even the Morse code could be a serial communication. Okay guys, so we have mentioned that clock pulses before. Depending on this clock, serial communication could be synchronous or asynchronous, and the main difference is that one uses the clock to send the data at a specific speed and time, and the asynchronous doesn't have a clock. So how do you know where one bit will end and where the next bit will start if you don't have any clock? To understand that, we start with the most basic asynchronous serial communication, UART or Universal Asynchronous Receiver Transmitter. This type of communication uses only one cable to send the data plus the ground reference. The transmitter cable will be named TX and the receiver will be RX. The transmitter starts sending bits whenever it wants. So how does the receiver know when the incoming data starts, where it ends, when we have a bit or the other, and so on? For that, UART communication will need to place some common configuration between the transmitter and the receiver. Before making the connections, you need to make sure that both the X and the RX will work with the same settings. Three of these settings are the transmission speed in baud per second, the data length in bits, and how is the start and the stop bit. So let's see what are these. Imagine that you want to send the number before 198. The representation in digital pulses of this would be this one. So with this data, we already know that we will send 8 bits. So now we know the data length. The transmitter and receiver must have the same configuration. But if we analyze the UART signal, we won't see only these 8 bits. We will see something like this. That's because UART needs a start bit and an end bit. Usually, the UART signal is always high, and the start bit will be represented by a low pulse. So that makes very easy for the receiver to detect when the data starts. Each time we detect a low pulse, we know that we need to start reading the input data. And now here comes the third configuration, the speed of transmission. Without knowing the speed, the receiver won't be able to know when one bit will end and the other one will start, and by that it will ring the wrong value. For that, we need to set the speed in bauds per second. A very common UART speed is 9600 bauds per second. That means that the length of the bit will be 1 divided by 9600, and that equals to 104 microseconds. So now all the receiver has to do after detecting the start bit is to count time. We count 104 microseconds, and then we are at the beginning of the first input bit. But we don't usually save the value here, because the data is unstable. So we will go in the middle of the bit. So we count 52 microseconds more. And now we save the first bit, and then we count 104 microseconds more and save the second bit, and so on. Once the receiver has all 8 bits, we'll wait for the stop bit, which is represented by a high pulse, and then we can send the received data from the buffer to the rest of the system. This exact same setup could be made with different speeds or different amount of bits for the same data. Usually, the start and stop bits are always like this. So that's how the UART communication works. Another version of the UART communication is the RS-232 that is used by old computers. The Arduino, for example, uses the UART communication to upload the codes or send the data to the serial monitor. This right here is a UART chip, and you will also see that it has a DTR pin, and sometimes you will see a CTS pin. These pins are used to notify that the data terminal is ready and that the receiver is clear to receive, so in this way we won't have flow problems. I connect the Arduino, and here I have the UART signal on the oscilloscope, and right now I'm sending the number before, 198. As you can see, we have exactly the representation before. The start bit, the data, and the stop bit, and the rest of the time the signal is high. Usually devices will have both the TX and the RX pins, so they could both send and receive data with the same protocol.
Okay, so I hope you guys have a basic understanding of what UART is. So in summary, UART is stands for Universal Asynchronous Receiver or Transmitter. It is used to send the code from no. So it's basically allows two devices to communicate with each other serially. The wiring connection for UART is very simple. So we have two devices right here. One device has the TX and RX, and the other device has the TX and RX. Once again, T stands for transmitter, and R stands for receiver. So the connection is that the TX of one device should always connect to the RX of the other device and vice versa. So like device 2's TX should connect to device 1's RX. And then we just have like one common ground in here. And I think that's it for the wiring of UART. Okay. Also sometimes this ground here, this common ground right here is optional, so you don't have to put it sometimes. So we're gonna go to our first example, which is the basic serial.println. So in the video, the guy said that UART is used to communicate from the Arduino IDE to your microcontroller, say your Arduino or your ESP32. So we do this through an object. It's not really an object. It's called the serial. So we use the serial to communicate from the microcontroller to the Arduino IDE. So again, we use serial to send data in series from our boards to the Arduino IDE and vice versa. So right here, we could see that UART is used to send the code from the IDE to the Arduino microcontroller, and UART can also be used to send the data from the microcontroller to the Arduino IDE. So again, we have a very simple example in here. This is just printing to the serial monitor. So the Arduino Uno, when you upload this code to your Arduino Uno or any microcontroller that you have right now, say ESP32, you upload the code using UART, and then you have the cable, right? Then the microcontroller will also send that string right here, which is the HAcK 2022, back to the computer or PC, and then it will show it to the serial monitor right here using also UART. So this is like a basic example. We're not really gonna do it. And then we're gonna move on to the second example.
Can I ask a question?
Yeah,
This is just between the IDE and the Arduino, or is it like between the ESP32 and the Arduino?
this is just between the a microcontroller and the Arduino IDE, like your Arduino IDE, the where you code it. It's not between two microcontrollers yet.
Okay.
Okay. And then the second example is the one between two microcontrollers. So in here, we're gonna allow Arduino Uno to communicate with ESP32 using UART. So again, the wiring is really simple. I want you guys to grab your microcontrollers right now and find the RX and TX pins on both the ESP32 and the Arduino Uno. It's usually at the ends of the microcontroller boards. And then once you guys find it, you wanna connect, since we're doing Arduino Uno to ESP32 communication, we want the Arduino to be the transmitter. So we put the pin of Arduino, or like the wire pin on the TX of the Arduino Uno, and then since the ESP32 is the one receiving, we put the wire pin to the RX pin of the ESP32, just like here. So as you guys can see, I didn't use a common ground, but you guys can use it. Don't do this right now. We'll have like time later to do it. Does anyone have any questions? 4, 3. Okay.
Can I ask a question?
Yeah.
How can we make sure that both boards have power? So we plug two cables all into our computer, or
Yeah.
we use one of the board to power up another?
You can do both. That's a good question. Yeah, you can do both.
Yeah. So if I want to, for example, I only have one. Let's say I only have one extra USB outlet on my computer. So I should, the ESP32 use 3.3, right? So I should wire the 3.3 volt of the Arduino to the 3.3 volt on the ESP32. Is that right?
Can you repeat what you said?
So if I want to power up the ESP32 using Arduino, I should use the 3.3 volt pin on the Arduino and connect it to the 3.3 volt pin on the ESP32.
That, or I think, yeah. So you have your the plug to your computer to the Arduino Uno, right?
Yeah.
So
So
your Arduino Uno is connected to your computer.
yeah, the Arduino
Okay,
is connected to.
that makes sense. Yeah, yeah, you can do that.
Okay, great. Thank you.
And then, so this is the wiring. It's just really one wire. And then the coding is the kind of a little bit confusing, but it like when you guys like get a hold of it, it's really, really simple. So don't look at the code right here first. Because it's gonna be confusing. I want you guys to look at this bottom diagram right here. So for the Arduino Uno to ESP32 communication, our main goal is that we want to send data, say a string called HAcK 2022, from the Arduino Uno to the ESP32. Again, this is possible through UART right here. And then from the ESP32, we want to send that same string to our PC or desktop or Mac or whatever you have, then to the serial monitor. So we're using two UARTs in here, one between the Arduino Uno, one between the Arduino Uno and the ESP32, and one between the ESP32 and your computer. Okay, so that's our goal. So now we look at the code. So since the Arduino is just gonna transmit data or send data, the code for the Arduino is really just similar to the code right here. So this one just sends data to the serial, to whatever serial it's connected to using the UART. So in this case, its serial is going to be connected to the ESP32. So whatever it prints, the serial that print ln in here, whatever that prints, that HAcK 2022, it will be sent to the ESP32 no matter what. Okay. And then,
so it's already uploaded on the Arduino.
oh no, you guys will have to upload this later.
Yeah, but we're assuming that like in this example, it's already on the Arduino.
Yeah, we're assuming. Yeah. Like, yeah, assume that the code is already in the Arduino. Like all of this code, like this code is already in the Arduino and this code is already in the ESP32. Okay. So that's just for the Arduino. And then the code for the ESP32 is kind of different because since the ESP32 is both sending and receiving data, so it's receiving data from the Arduino Uno and it's sending data to the PC or desktop Mac or to your computer or something. We need two serials for the ESP32. Let's see. So one is the normal serial right here, which is the serial with no number, and the other is the serial 2. So you might ask, like, why is it not serial 1? So serial 2 by default, correct me if I'm wrong, is connected to the RX pin of the ESP32. And then serial 1, which is right here, note here, it's connected to the TX of the ESP32. So whenever you wanna receive data from the ESP, or like whenever you want the ESP32 to receive data through UART, you will use serial 2. And then if you wanna transmit data, you like not to your computer but to another microcontroller, you will use serial 1.
Wait, can I ask a question?
Oh yeah.
Why is it not serial 1 that began for the Arduino side then?
So wait, this one?
Yeah.
So we're gonna go into that, but Arduino Uno only has one serial.
Okay.
But it's gonna be in the next example though. Wait, that was you, Ming, huh? I
That was
don't know.
me. That was me.
Yeah, I was like, okay,
Slava had a question. He raised
Oh.
his hand, but then he didn't. Do you have a question?
yes. Do you have a question? Slava?
Yeah, I was about to ask why is it called serial and serial 2, and how does ESP32 know that serial 2 is received? But you just clarified that it's by default. So yeah,
Yeah.
no question.
Yeah. And then let's see. So again, so in here in the setup section of the code, we just initialize, like we always do, we initialize the serials. And then this block of code right here with the while loop, we're just basically saying to wait until there's like an available serial 2. So it's gonna loop here until like a data is sent to serial 2. And then when we go to the loop here, this thing is kind of similar to here, but then it's like saying that only enter this condition if like a data is available, so we can print that data. So here we know this serial.println. So we print the message received, and then we print whatever that is being sent by the Arduino Uno to the ESP32, which is HAcK 2022. We use serial2.read string as the function to read a string from serial to or from like the RX pin of the ESP32. You guys have any questions with that?
What's the difference between 02 dot available and in the while loop, while how to say that? While exclamation mark 02. Like what are the difference between these?
Oh, you mean like this while and the if here?
Yeah, the while and the if here.
Okay,
Like,
I didn't say it properly. So here, so we said to serial2.begin, right? So
mhm.
this thing right here will always begin when you're connected to your computer, or like when there's like a serial monitor in your computer. So serial 2, you don't know if there's like really a microcontroller that's sending the data to the ESP32. So you had to wait if that serial 2 is present. So in here, it's kind of similar, but then because this is just the first time, this is just a setup and this is just a loop. So whenever we loop, we want to like only print when there's like a serial 2, or like when there's a data available in serial 2, because this is loop and this is just a one-time thing.
Okay, so it's like if we want to transmit data to ESP32, we just use the 02 dot begin with the speed that we choose, and we add a while loop there in the setup. So that is the default thing whenever we use ESP32. Okay.
Yeah.
Okay, that makes sense. Thank you very much.
Okay. Yeah, so did everyone get this diagram right here?
Can I ask a question?
Yes.
So my question is for the Arduino, when we do serial.print and serial.begin and then we do serial.print. So normally when we weren't doing UART, it would send HAcK 2022 to the computer. But now it's sending it to the ESP32. So when we send HAcK 2022, is it both sending it to the computer as well as to the TX pin, or is it just the TX pin?
So that's actually a good question. I think it's only sending it to the TX pin to the RX pin. Or wait. You could actually get, I think it's sending it to both. You guys can try it later. I'm not sure. Cause if it's this one receiving here. Oh yeah, I think it's sending it to both.
Okay, so then when we send it to the ESP32 and then the ESP32 sends it to the computer, will we receive that message twice? Because one's from the Arduino?
No, because you so only if you open this, because remember you can only open one serial monitor port at a time. So when you open the Arduino side, it will only show HAcK 2022. You cannot, I think you cannot open this serials at the same time, like both the monitors at the same time.
Oh, okay, that makes sense.
Okay. Is there any more questions?
So this serial monitor is only for the ESP32 serial monitor.
Yes.
Is there a serial monitor for ESP32?
What?
So in this case, only one of the two boards is connected to the computer, right? So so the ESP32 can actually like get powered up by Arduino. So this is also like a serial for ESP32 specifically, even though it only has something that is receiving data.
I think I get your question. So I think I didn't explain it properly. So I forgot. So in order to send from the ESP32 to your PC, you need to connect the ESP32 to your PC using the USB cable.
Oh, okay.
So you might just want the power of the Arduino Uno using the ESP32. You can use the USB. There's a pin called USB, and you can just connect it to the Arduino Uno.
Okay.
And then I think we're almost gonna go breakout rooms. Oh yeah. So before uploading your code to each of the microcontrollers, ESP32 and Arduino Uno, remember to remove the wire right here, because they are all UART, right? So it'll be confusing for the boards if you upload here and they're also communicating in here. So make sure to always remove this whenever you upload the code, because this one, the USB here, this one, and this one are all UART. So just a warning. And then before we go into breakout rooms and test example 2, I want you guys to just test this one and make sure that it works. There's not really like a exercise in here. I just want you to like make it work on your own microcontrollers. I created a like debugging steps right here that you might want to use when your code or when things doesn't work. So always check your wiring, your baud rate, the power, and then remove the UART connection before uploading the code. And then right here, this one is important. So I think one of you asked about like, does the ESP32 really know that it's like that serial 2 is for the RX? You can actually specify it. So what you would do is like just type this. So instead of just serial 2 that begin and the baud rate, you would type serial 2 that begin the baud rate, and then just copy this. This is just like a macro, and then you put the pin of the RX in here. So this is they only do this when the code above or like the code in the previous slides doesn't work. And if you're still stuck, ask the mentors. And I think that's like that. And then I think we're gonna go to breakout rooms now. I'll be hopping into like each breakout rooms. Before we go into breakout rooms, does anyone have any questions? I'm gonna paste this.
Why did you say we need to remove the cable when uploading it?
Okay, hold on. Here. So, cause I use like I have a lot of USB hubs. I use them both. Like whenever you upload it and both are powered on, they're still communicating, right? Like this one right here. Remember the guy said on the video that uploading the code from the Arduino IDE to the microcontroller, we use UART, and this one is also UART, right? So it will be confusing for the boards to like know which one should it like.
Okay.
Got it.
And then does anyone else have a question? Okay, I think we can go to breakout rooms now then. I'm gonna post this later.
I think you get assigned to room 3. I'll go in room 3 so you can go around.
Okay.
Yeah.
Recording in progress.